Okay, we're now going to be testing a Tesla EL34, and basically I've already set it up to do that, and I'm going to come up here and hopefully I won't be too wiggly and show you that the numbers on the selectors are now all different, and it's going to be rare that you have anything over here, these last ones. That's more for multi-element tubes and compactrons and that kind of thing. So I'm going to now back us off here a little bit, and I'm going to bring the camera down so that you can see the face of the tester a little bit better. And okay, I think we got it. So as before, we're sitting here on the cold insulation check and anode 1. Now this tube does not have two anodes, so we will not be using anode 2. We're only going to be using anode 1. Some tubes have 3 anodes, so here you have 3 up here, but we're not going to be concerned about that. You will also note on this side D, this is all for diodes and rectifiers, and I recommend that you read the manual on it. It pretty much applies the same way as what we have done just now on the 12AX7 types and what we're going to be doing on this one. And you will see that this one corresponds with this area over here where you're going to be reading current for diodes and rectifiers. So now we are, as before, we are sitting in cold check, cold insulation check. We're going to see if the filament is good, and the filament is good, and now we're going to go around and check for the rest of the insulation and see if it's good, and it is. We're back to the line check over here. Next we're going to turn it on heater and let it warm up, and I'm going to look at the line here, and it has changed, so I'm going to go ahead and give it one little notch up, and now we're on the green again. We're back on the green line. Get as close as you can to that green line in the center of that green area. It's not quite in the center, but if you can get on that line, the better. But inside of that line, you've only got maybe 2 volts difference on your AC power coming into this machine. In other words, if you're on this side of the line and you have 122 coming into your house, you might be 120. If you're on this side of the house, this side of the line, you might be at 124, something like that. So at 122, that's what we're showing here, or this is just an example. If you're set up that way and you're on the line, then you're done. Going to go ahead and give this just a little bit more of a warm-up. Now, what we have done also in the meantime is we have changed, our anode volts are the same at 250, just what the manual says. We have now set up the screen also at 250, which is what the manual says. We have changed our grid volts because the grid volts are going to be higher, or actually lower, than the other one, than the 12AX7. So we're on the 0 to 30 scale because the manual is calling for 13.5 right here. So we're going to use that inside dial once again to get to 13.5. And what we have is 1, 2, 3, excuse me, let me get on there again. 1, 2, 1, 2, 2, 3 and a half right there. That little short mark right there is half. So now we're at 13.5. Now again, it's calling for 6 volts on this, not 6.3. So we're going to go ahead and do what it says and put it at 6 volts. And we should be warmed up enough. Let's see what kind of insulation we have on this, how perfect it might be. And as I go around on the leakage switch, we see it's not showing anything. We're back to line set and the AC sine wave line set mark, which is right here. Now we're going to go ahead and test for heater cathode, so we're going to go up there. And let's see if we have any. And we don't have any heater cathode leakage on this tube. Excellent, excellent. Power tubes have a tendency to want to do that, want to show heater cathode leakage. And again, when I mentioned earlier that if you show something over in this area in the 250 million ohm area, that's 2.5 million right there. 2.5 million is that mark right there. From there on, I would not worry about it on a power tube. The closer you get to this mark, this 1, which is 1 million, then you become kind of concerned. It might be something you want to watch once in a while, recheck after a month and see if it gets any worse. If you come to this side, then I would be very cautious, especially depending on where this power tube is used. In a guitar amplifier, which gets hard work, or in a very high-powered amplifier played loud, you might drive this heater cathode insulation to more and more and more of a short. And once you get down over into here, I wouldn't use it at all. It's too close and too easy for it to avalanche down into a full short. Once it's there, you're now going to have to fix your amplifier. So let's not be too greedy about what we're going to be using in what amplifier. Okay, we are heater insulation. We're showing nothing. Well, actually, no, we're showing nothing. We're beyond 250 million ohms over here. 25 million ohms over here. No heat. Excellent, excellent, excellent. Let's go to test and see where we are. Okay, now you will notice that we've gone from 0.6 over here for our GM, or milliamp per volt, to 0 to 20. Now actually this is 0 to 20,000. Again, you have to use a little common sense here on whether or not you're looking at 20,000 or 2,000 or whatever the case might be. And when you look at your sheet, you should be able to understand what it's telling you. The machine itself inside changes the way it's displayed over here so that you are not going to show 2,000 when it should be 20,000. It's readjusting itself as you turn this knob or that knob or any of the other knobs. It's readjusting itself. So if GM is approximately, according to the sheet, the GM is approximately 11,000, and over here we are showing 10,000 right there. See, we were on the top scale for the 12AX7. Now we're on the bottom scale. So we're showing a little over 10,000. We're actually showing 10,500. The data book on this one says 11,000 is nominal new. So you're really, really inside that area of nominal new. And what are we showing over here for current? Right now we are showing 60, 65, 70, 72, and the data book says 75 for brand new. Let's let it sit here and warm up a little bit more. Let's go back over here and recheck and see if we're still on that line. Yeah, we are. Okay, so we're still on there, and this still keeps the tube hot. Go back over here, and we're going to go and check it again and see if we've gotten any better. No, the GM is still about 10.5, and the current is still about 72. All right, let's see what happens when we go to 6.3, which is what the later edition says. And that's going to take a moment to do anything, if it does anything at all. And we have still 10, little more than 10.5 over here, a little bit more than 10,500 showing over here, maybe about 10,007, and on current we're showing 74. So you can see it changed it a little bit, but not dramatically. And of course, as I was going to say earlier, we've now gone over here to measure this current. We've gone from the 3 milliamp range for the 12AX7 all the way up to 100. So we've gone from this lower scale over here to the top scale over here, the 0 to 100, because this tube is measuring about 75 milliamps. So we want to be on that top scale. And the same thing is over here. We don't want to be on 2.6. You're going to be, pinning the needle. So that's pretty much it. Now the next thing we're going to do on this power tube is, let's see, these are such nice numbers. I wonder if it's got any gas. If it has gas, that could be boosting these numbers up. So let's see if it's got any gas. And it is showing, basically 1 first division right here, which will be 1 microamp of gas. That's nothing. That's absolutely nothing. Nothing to be concerned about. So let's go back to test. And you can see we're just a little higher now. We might be a little closer to 10,800. And we're still at about 74 on the current. So let's see if this tube, how much this is drawing for the screen. This is your screen here. G2 is your screen. Let's see what we're burning for the screen. Now this is additive for most testers. It's going to be additive. And we're showing about 10 milliamps on the screen. That's in the neighborhood. Maybe slightly high. Most testers will add the screen to the plate. This is your plate, period, without the screen. Most testers will add these two together to give you a different current value. You have a triplet 3444. It won't do that. Particularly if you have the current meter, the digital current meter, you're only showing the plate, you're not showing the screen. So it's giving you a more true value. So that's pretty much it for this test and this tube. It's stable. It hasn't gotten any stronger. If we let it sit here another 5 minutes or so, you might get just a little bit more out of it. I mean, I can see that we're already creeping really close to 75 over here. We're about 74 and a half, and still sitting over here at about 10,800. I'm going to go back to 6 and see how much we drop now that the tube is really warmed up. And it has not really dropped any. The GM has dropped maybe to 10,006, and your current over here is dropped to 74. You're back to where you were. So that's pretty much it on the power tube. And all your power tubes you're going to be testing basically the same way as we just tested this one. I'm not going to do diodes and rectifiers. That I want you to go through the manual on, and you will find the procedures exactly the same as for testing a power tube. You just simply will be using this part of the dial over here for diodes, and this part of the dial over here for the diode currents. You'll still be using, well, you won't be using that. That's it. That's it. Reading the manual can become very confusing and overwhelming, but once you do this a couple of times, you'll realize it's just really not that hard. So that's your video for how to test a preamp tube and a power tube, and it's going to hold for all the rest of them that you're going to be testing. And that's it. I'm signing off, and good luck.